Good morning, guys. So after seeing the reaction of Favorskii, we do have this example. So the mechanism of this reaction is not going to be very different from the mechanism of the reaction of Favorskii. So let's try to write it together. So under basic conditions, we do have H2 minus. So we're going to look up for the most acidic hydrogen. Why? Because it is going to be acido-base reaction. Okay, so this one is alpha position, this one too alpha position, but here we do have three hydrogens. However, here we only have one, so the most acidic one is going to be one of these three. Okay, so we're gonna form C minus. Okay, so a formal charge, a negative formal charge on the carbon. So let me just redraw the molecule. Well, okay, chlor, and then we do have C double bond O attached to CH2 with a negative charge, okay, on the carbon. So as you can see, we can form like we have formed the enolate. Okay, so it is called enolate. So let me just draw it again here to sorry, okay, chlor, and here we form alkoxide. This is the alkoxide form, a negative formal charge on the oxygen. And here we do have a P bond, okay? CH2. So remember, it is never the oxygen with one of the lone pairs that is going to attack, okay? No, it is always generally, well, I can say always, but in general, like the enolate form, which is going to attack. So this minus charge is going to attack, okay? So let me just zoom in. Okay, so let's just focus on this molecule, okay? Okay, so in presence of a chlor here, this carbon holds a chlor. The chlor is minus E inductive effect, right? So this carbon has a partial positive charge, okay? So the chloride is very electronegative. So what we are going to do, it's kind of an intramolecular reaction, right? So this minus charge is going to attack the carbon that holds the chlor, and then we like the chloride is a good living group, so we're gonna have minus chloride, okay? So let me just redraw my molecule. So I do have here the part that hasn't been like changed. So here is my carbon, this one in red, sorry, in green. So I write it here. So I draw it here, and here I do have this one, okay? So this bond that just that we just formed. So CH2 with this bond, okay? So let's try to well, let's just try to find what we should do after. Like we do have another molecule of HO minus, okay? So we're going to, here we don't have, well, we're not gonna attack another hydrogen, okay? It's not gonna be, sorry, it's not gonna be the best thing we have to do. It's going to be here, sorry, it's going to act as a nucleophile. So here we do have this carbon, which is positively charged, like a partial charge. So we're gonna attack here this carbon, and then we're gonna form either we go this way, or we go, let me just choose another, well, I'm gonna choose the red one. We go this way, okay? So let me just write both of them in red and then in green, okay? So in red, in green, it's gonna be here, okay? In red, I'm gonna write it here. Sorry, well. So I do have my molecule with this one here, and then I have this one. Okay, so this one, here I have CH2, and then I do have CO, okay? I added OH, okay? So I still have to add something, which is the negative charge on this carbon. So on this carbon, I have a negative charge, okay? So then if I tried the green one, well, I tried to draw the molecule again. So this one like this, and then this one with, sorry, with this one. So I'm here right now, and then I have CH2 with CO, and then on the CH2, sorry, here we do have OH, this one, and on the CH2 I have a negative charge, okay? So I put negative charge here, minus. So which one is very stable? So this is the question, okay? So as you can see here, we do have this like this. So we have a resonance form, okay? So a resonance form. This minus charge is stabilized, okay? It's stable. However, this one, it only has this like this, okay? So it's really this one that matters. So yeah, this one. Okay,